Today we've got a great panel here for you, and we're here to discuss active energy and mechanical equipment management in the context of making your retail rentals more competitive. With active energy management and using existing technologies, you can greatly reduce your operating costs and better manage or dramatically reduce your capital plan. The energy profile and types of equipment differ greatly depending on the type of application or tenant that you have in your space. It costs a lot less to properly maintain your equipment with the appropriate measures and controls in place. So today I'm going to introduce the two speakers. But first, I have a couple of housekeeping items. Should you wish for a copy of the presentation, we're happy to do so. We don't receive a list of the attendees, so please do drop off a business card here at the table. Happy to send that out. And for those of you who might like to discuss our energy management, metering, or HVAC services, please do visit the Enercare booth at booth number 1717. So with that, I will move on to introducing our speakers. The first speaker today is Daniel Zacarelli. He is the Manager of Engineering and Technical Sales with Enercare Commercial Services. Daniel holds a professional engineering designation with 12 years plus experience in metering, project management, HVAC and hydronic, and designing HVAC and hydronic systems. In his role at Enercare, he's responsible for HVAC design, project oversight, new product introduction, and spends a lot of time working with customers to make sure they're getting the right solutions. Our second speaker is Mr. Wilson Chung. He is the Manager of Field Support and Product Integration at Enercare Connections and has been with the organization since 2015. Wilson is a professional engineer and certified measurement and verification professional with 10 years experience in energy consulting services for commercial properties, including tenant utility cost allocation and recovery, ASHRAE Level 1 and Level 2 energy audits, engineering feasibility studies, and capital project management. At Enercare, Wilson leads the technical services group, which is responsible for all engineering aspects of the submetering business from installation to operations. Wilson is also the resident expert on energy systems and is relied upon to deliver custom projects, including the calculation of thermal billing rates and development of custom reporting solutions. So with that, I will introduce Daniel Zacarelli to walk through his presentation.
As you guys know, I'm Daniel Zacarelli. Pleasure to be here today. Thank you guys for coming out to hear us speak, and hopefully we have a few insightful topics for you guys to take home with yourselves and help further your business in regards to HVAC and energy management side of the things. Your HVAC and hydronics are a key part to your customers, clients, residents' comfort and experience while attending your property or in your facilities. And thus, provisioning for HVAC and hydronic equipment is a key part of your business. I'm going to discuss three different spaces here and how dynamic the HVAC and hydronic needs are for these spaces, just to kind of help give you an idea, understand the differences and the things that you should be thinking about when provisioning for HVAC and hydronic equipment. The first space I wanted to speak about is event spaces. So event spaces are very regular when it comes to heating and cooling, your heating and cooling requirements. They require the ability to provide conditioned air in a very dynamic environment. So for example, there could be times where you have your event space with a concert and you have heavy lights on and providing a lot of heat, so the cooling is at a higher load. The capacity could be at higher amounts, the capacity could be at lower amounts. So having that dynamic ability to condition your air and condition your space is a very important item to think about when designing your HVAC. A great system that we use in a lot of scenarios and we've seen a lot of success with is a variable refrigerant flow system. Providing different heads to the areas to provide this conditioned air throughout, moves the air in many different areas at one time, but also provides you with the ability to control the temperature that's coming from each one of these specific areas, as well as the actual flow that's coming out of these areas. So you can have, for example, if a stage up here up front, lots of lights, lots of heat, heavy cooling might be required for this area. So you can have a fan that's providing heavy flow with very cool temperature to this spot, but your next head that's further out there with the crowd sitting around, if it's not as busy of a night, providing a little bit less on the cooling side and a little bit less on the flow side of things, on the fan speed, for example. So it gives you that dynamic control throughout your property to allow for comfort at all areas of your venue. Another area where we see a lot of people having issues with their heating, cooling, hot water side of things is restaurants. Restaurants have a large amount of exhaust air. As you can imagine, larger kitchens have these massive exhaust hoods, and then just as a general number, you're looking at about 400 CFM per linear foot that's being exhausted out of the property. A lot of these restaurants don't provision for proper makeup air units to return fresh outdoor air for the exhausted air that's come out of your kitchens or your bathrooms and things like that. So you can, I'm sure everybody's been to one of those restaurants where you kind of walk in the door and you try and open it and you kind of need both hands to kind of pull that door open. That's a restaurant that has a big negative air issue. And a lot of people, when they design these spaces that have a lot of exhaust ventilation, don't think about that air being replaced back in. They think, oh, I've got a rooftop unit that's providing me with my heating and my cooling, but that's kind of circulating the air throughout your property. You supply heating and cooling, it comes back through the return. A little bit of outdoor air is brought in at the same time, but it does not make up for your exhausted air. The exhausted air is sized for specific reasons, and then your makeup air will be sized based off of the exhausted air that comes out of your property. So without having a unit like this, it creates the discomfort for the tenants and the clients and people you have in your properties, but as well as the equipment that you have in your property. So for example, water heaters, boilers, the more conventional type bring in air as they need to combust the combustibles. And if it's under a negative pressure, it's not able to breathe. Imagine a room is sucking all the air out, and as you try and breathe in, you can't, as a human, can't breathe in yourself. Equipment works in the same fashion, and that leads to heavy degradation of your equipment. Life cycles we see cut in less than half for these water heaters and boilers, for example. So it's not just your tenants that are uncomfortable, you're sucking out all your heating and your cooling that your rooftop unit's putting in there. Tenants are hot, cold, uncomfortable, doors are difficult to open, but also your equipment, your even things like gas-fired stoves, for example. You're degrading the life of the equipment, increasing costs for breakdown, increasing costs. Maintenance is at a much higher level required for that, and if you don't provision for a makeup air unit, your other option is very expensive equipment that does not need that is sealed combustion, for example. The third space I wanted to talk about is electronic displays. As you can all imagine, electronic displays get very hot. So for example, the Apple Hyperwall. There's 25 separate screens in this Hyperwall, and it gets very hot, and as the fans behind it blow out the warm air into the space, it creates a discomfort for your tenants. And this is meant to be more of an idea generator for yourself to think about these scenarios that provide that have these types of equipment. It could be in your event space. You could have, your big wall of lights and things like that. So it's just one of those things to think about as you design your HVAC, that it's not just kind of your square footage, not just your space that requires a certain amount of ventilation or a certain amount of heating, certain amount of cooling. It's also the people in your property, the equipment that you have, the dynamic situations that go on. There's a lot to think about in designing HVAC for these different dynamic spaces. The next thing I wanted to talk about was active management of your HVAC and hydronic equipment. Understanding the installation as well as the maintenance side of things when it comes to your equipment, and developing a proper plan for these two things helps out greatly in the long run in the life of your equipment. So for example, preventative maintenance side of things, regular maintenance, as everybody knows, and I'm sure everybody does for most of their equipment, One of the main things there that you're missing if you don't do your regular maintenance is the efficiency and performance of your equipment. So you go out there and you buy these new high efficiency pieces of equipment, and you don't maintain them, and they lose their efficiency dramatically within the first 6 months. And then after that, you're just choking a piece of equipment, for example, a rooftop unit. You don't change your filters in that. Try breathing through your hands when your hand's closed in front of your mouth. It's very difficult to do. If your hand's open and free, you can breathe through it freely. So you're losing your efficiency with that, as well as the physical air that's coming through is not cleaned, not comfortable for your tenants. So as much as our customers like to think that a little bit of preventive maintenance here and there, once a year, once every couple of years, suffices for their equipment because their equipment doesn't break down, there's also the comfort level that has to be thought about. The other part of preventative maintenance is it helps protect your equipment's useful life. As the equipment strives for air, for example, I'll continue with a rooftop, it's working harder. As you work harder, you're reducing the life of the equipment. The motors wear and tear quicker. Your belts are going to wear and tear quicker. And the life will be cut. Usually we see actually life cut in half in these situations. Another important part is keeping your equipment safe. A lot of equipment combusts, for example, natural gas. Without preventative maintenance, without cleanings, they can carbon up, for example, and then start to smoke or provide carbon dioxide into common areas where people may be working, living, and entertaining, or having dinner or lunches, whatever it may be, in whatever space you may have. And the last part there is actually quite an important one, minimizing emergency repairs. A lot of the time where we see these emergency repairs come up is in the busy season. The busy season is when you use your equipment the most, when everybody's there, when you're really pulling all of that heavy work out of your hopefully properly sized HVAC and hydronic equipment. Without that preventative maintenance, you have much higher risk to break down in these high seasons. And a breakdown in these high seasons, it's when you're making your money, when your business is flourishing, and you now have to shut down your restaurant, for example, because there's no hot water and you can't get a technician there till the next day. Then in regards to visibility, a lot of people go out there and kind of, hire an engineer and say, this is my space. They may not explain to them exactly what's going on with it. I've got a room that's this and that big. I've got some of this equipment in it, and some people are going to be in there. I need some HVAC equipment designed for it. So you think, okay, great, HVAC equipment's designed. I'm ready to go. I hired this company here to do a preventative maintenance thing. Check the box. Forget about it. Don't worry. Don't check. Don't care. When the equipment breaks down, that's when I wake up again, and I want to go out there and figure out what's going on. But without regular checks and understanding what preventative maintenance is actually being done and not being done, you don't actually know what's going on with your equipment. Without understanding what an engineer really needs to know and understand for your space, they may not be able to design the equipment that's required to condition your space. So I have 3 case studies that we've conducted here. The first one is a retirement home. We walked through this retirement home and just kind of looked at all of their HVAC and hydronic equipment and provided a list of different deficiencies. Some of them are code related, some of them are just efficiency related, install related, sizing related, things like that. So we saw, for example, here, newly installed boilers in this building were installed not to code from their venting side of things, and that's not something maybe a building owner would know. They come in there and they see venting looks nice, clean, new, everything's okay, but it's not the proper venting. You have PVC pipe coming out when the boiler might require CPVC pipe. Telling the difference between them, really understanding the difference between them, really, most people may not know, some people may. But things like that are easy to slide by. The other thing that we did notice was there's not just the code requirements for this scenario, there was also manufacturer requirements. So the manufacturer required of the boiler required that a special coupling be put in for the first 12 inches of the venting, and that coupling was not there. And that's not something that an inspector would care so much so about or really even catch. And that's one of those things where having somebody available to you that has that knowledge, has that experience to give you this information greatly helps out in the property. So things like that, void warranties, don't allow equipment to function properly. Simple things like gas piping not being the proper color. Not a big deal, not too detrimental to anybody's safety or health, other than gas pipe's supposed to be yellow so that you identify that, yellow pipe, don't play with that, gas is inside. But TSSA comes and sees it, and then all of a sudden TSSA opens their eyes to everything else in your property. And the last thing you need is an inspector walking around, I saw this thing wrong, oh, now let me see what else is wrong in your property. Just creates headaches. We also noticed in this property that the design of their storage tanks on their domestic hot water was kind of, for lack of a better expression, inconveniently done. Their manifold system with all their shutoff valves was piped behind their storage tanks. It makes it difficult to service. There was still ability for someone to get in there, kind of shut things on and off, but what they didn't think about is what happens when something leaks? What happens when my copper gets a little pinhole? How am I going to get a person back there with all their tools ready to repair that issue? Having the manifold properly piped around the front makes it easier for those maintenance and repair issues. Another thing is the pressure reliefs on these storage tanks. Every now and then pressure reliefs go, a little bit of water comes out. They're supposed to be piped in a direction towards the slope into the drain. If it's piped at the back of the storage tank, for example, and the slope goes underneath it, you can imagine that water is going to flow underneath your storage tank, get stagnant every now and then, start rusting through, cut your storage tank life in half again, and start, as it rusts, a little pinhole leak happens, and with the amount, like 200 gallons of water, heavy, a pinhole leak turns into a leak the size of your face very quickly. Floods your boiler room, insurance costs, hot water down to your tenants, heat down to your tenants, whatever it may be. So thinking about little things like that, having someone helping you with those little things helps you stay away from these issues happening to the best of your abilities. Another thing that we saw in a lot of different buildings, and you'll see it actually reoccurring in the other two case studies that I have, is improper maintenance of specifically exhaust fans. Exhaust fans in commercial properties are plentiful. They're everywhere. So a maintenance person will go out and see 40 exhaust fans on a rooftop and forget where they're going and not have an idea of one after the other. They'll be like, oh, I thought I did that one, and I thought I did this one all the way at the end of the roof. Oh, no one's ever gonna go out there. I don't need to look at that one. It's cold today, I wanna go home. A lot of those things actually happen, and we found several scenarios like this in this picture here, the top right, where the belt was actually broken. And in this case, you have your motor spinning at full speed using your electricity and no exhaust being vented out. In this case, it was a bathroom exhaust, so none of that bathroom smell, exhaust, vapor from hot water or anything was being vented out, and nobody knew the difference. They're just kind of like, oh, okay, I just guess that's how this bathroom is. Without proper preventative maintenance and visits, things like this get missed. And then a big thing with this property in specific, we had 3 rooftop units that were placed on the floor because it was a bungalow property and then ducted into the building. As you can see in this picture, it's not insulated at all, and that's a very long duct run. You can imagine in the very hot days, the very cold days, you're losing all the efficiency, all the heat, all the cool that's running through that duct, but by the time it gets into your property, it's hot on a hot day or it's cold on a winter day. And this property specifically was one in their portfolio that used the most amount of electricity out of any of the other properties that they have, and they couldn't really figure out why. This is a huge reason why, and this led to the second biggest reason why. The tenants in this retirement home had electric baseboard heaters that were there for the 1 or 2 very, very cold days a year to supplement. They were using them all the time because the air that was coming in by the time it got into the property was already fairly cold. You've got your unit running 24 hours a day to try and keep up, try and get that warm temperature in there. You can't do it. Our second case study is a hotel that we visited. In regards to our assessment results, and this property actually had a lot of issues. I wanted to highlight just a few of them. One of the more serious ones is in their boiler room, they had a bad negative air problem. And these boilers are older boilers, atmospheric. So as they were not venting properly, the negative air was sucking the CO2 back into the room. When CO2 comes back into the room, it drops down. These boilers, being old atmospheric boilers, breathe in from the bottom. If they breathe in that CO2 and it's part of that combustion procedure, it turns into carbon monoxide. And carbon monoxide, as we all know, is very deadly. If a room is filled with carbon monoxide, you have matters of seconds to get out of there before you lose consciousness and you can lose your life. So with this issue, it's partially in regards to not proper ventilation in the room, not proper combustion air in the room, sized by your boilers and the HVAC equipment that you have in that room. There has to be, by code, a specific amount of combustion air coming into that room, ducted to a specific area within 18 inches of the floor, for example, within that room, and we saw that these issues weren't there. Another issue that they had was that they had a makeup air in this room as well. That indoor makeup air unit, once we open it up, looks like it was, give or take 15 years old, never once maintained. We pulled the filter out of it and it was worse than the filter that you see there in the top right. It was completely plugged. So as that unit is struggling to get the outdoor fresh air through the filter that it can't breathe through, it's actually pulling air from that room in any of the cracks and the holes and the openings in the side of the unit. So that's creating also another large part of that negative air issue. And without properly licensed technicians, experienced technicians, or an engineer or someone there to help you with those things, it's difficult to have that understanding or see those things and be able to repair them. A lot of other issues in this property were involved with the venting side of things. It looked like the person that did the venting on the boilers in this property kind of just slapped it together and didn't care. It was one of those things, this thing vents out, so just put a big steel pipe there, stainless steel pipe, and let it vent out wherever it's going. But the vent sizing is important for allowing the flue to naturally draft out. Without that natural draft, it creates issues, for example, like that one before, where CO2 comes back into the room. And then just in general, similar to the other properties, you've got pictures here of filters that look like they haven't been changed in years. Burners here, for example, that because they haven't been cleaned in a long time are starting to rust and combust on themselves. I'm sure if you pulled one of those burners out, they may start to even disintegrate kind of in your hands as they pull out from the age of that unit. Our third case study was a rental apartment property. There was even a simple thing like the gas meter station, which belongs to Enbridge. It's a free fix if there's any issues with it. You just have to realize that there's an issue, call Enbridge, and they come out and fix it for the property for free. We realized this issue. The property didn't even realize that it was an issue. It was actually pretty much getting ready to fall over, and a pounds gas line that falls over and breaks like that can definitely add a lot of gas into the air in a rental apartment building. Very dangerous, and it's difficult to turn these lines off. It's not like a little gas line over here broke, hit the shut off, and you have multiple shut offs in your property, you're good to go. With a line like this, it's a little bit more of a task. The seized bleeder valves on these boilers that we noticed. Because these boilers had not been maintained, the bleeders valves had corroded and seized. Just simple maintenance, simple quick things that a technician comes out and does helps from these issues happening. And because these bleeder valves seized, you're not able to continue to maintain this equipment anymore. So it almost ends up being, if I touch it, it falls apart. So leave it in there until it dies, but then it dies and my tenants don't have hot water. What do I do? Venting, again, another issue we see a lot of. In this specific scenario, they had what seemed to be custom tees that were created out of tin. Someone just kind of slapped them together, looked like child's play kind of a thing, and it had a lot of holes in it when it connected with that tee. And in this part here, as it connected up, it had a lot of holes in it, and those holes are conducive to CO2 coming back into your boiler room, burning, creating CO, spreading throughout your building, issues like that. Boiler supports, for example, something that's quickly overlooked. We had a few boilers here. If you look in the bottom right-hand picture there, One side of it is held up by a brick, another side is held up by a piece of wood, another side is held up by some shims. As the wood degrades, the boiler starts to shift. As the boiler shifts, the connections break. As the connections break, you fill your boiler room with hot water. We recently had a customer whose boiler room filled with 5 feet of water before they realized that their boiler room was full of water, and then they had to replace everything. They're 3-year-old, almost brand new boilers, their pumps, the electrical in the room. So even though you have insurance for those scenarios, your insurance goes up. Dealing with the insurance company is always a nightmare. It's always easier to have things go well in your buildings, and then dealing with your tenants. Now they're out of hot water. We have to scramble to get boilers from who knows where overnight. Try and install them. It takes sometimes days to get this equipment up and running when you think about large boiler rooms. So just for the key takeaways that I hope that we got from my quick chat here, one important thing is to work with your tenants and customers and understand what their heating and cooling issues are. These are the people that are constantly in your property and that can tell you those odd times. Late at night it's always cold, early in the morning it's always hot. The hot water is never good at 7 p.m. when everybody gets home and uses it. Little things like that can trigger ideas and repairs and comfort level increases for your property, for your tenants, for your customers. Taking the time to evaluate your HVAC equipment with preferably a third-party company, someone that's not involved with your property or with the equipment or the work themselves. An engineer who understands the equipment that's there, who understands the dynamic space and needs that you may have, or an experienced technician, technician that's been out there for a long time, that's had a lot of experience in those specific areas. Having people like that with you to help you through these walkthroughs greatly do help. Considering smart technologies is a great thing. Sensor technologies that help predict equipment behavior. This can also lead to energy savings, adjusting schedules. It'll tell you that if I adjust my chiller schedule by this and that amount, that I should be seeing some savings. You adjust it, you see your savings. You can adjust again, you can see more savings and continue to do so until you get to that optimal space. Without these smart technologies, you kind of install these energy guzzling pieces of equipment and just hope that they run fine. You turn your switch on and it just runs. Whereas you could be saving lots by giving it a proper schedule to go with. And then looking at cost-effective ways to reduce your energy consumption and extend the life of your intensive HVAC systems. Thank you very much. I hope that I've imparted some wisdom today, and please feel free to leave a card, and I'd be happy to talk later on or at a later date for any questions you may have.
Thank you, Daniel. Appreciate that. I think in terms of some of the examples that you walk through, these are professionally managed buildings. So it's not just the case where you can pick a property where it's a one-off. Some of these are large public companies that do a lot of acquisitions that spend a great deal of money on energy and HVAC equipment. So I think those were great examples that Daniel put forward to show you that even though you may have preventative maintenance contracts in place, the work may not always be performed to the standard, particularly if your contractor knows that there's not a lot of monitoring and verification going on your equipment. In terms of the tenant space, I think, as Daniel noted, understanding the unique requirements of each tenant is something that we recommend to landlords. There's not a lot you can necessarily help your tenants with in terms of the space. If it's a restaurant or a boutique store, obviously they're going to pick the finishes, they're going to pick the interiors. They have a vision for their business, but generally that vision doesn't include a lot of the boring stuff, like how am I going to supply heating and cooling? It's just taken for granted. So we always recommend that landlords work with their tenants, view HVAC design as a value-added service that you provide to your tenant. They're going to be installing things in your property. They could do damage to your property if they're improperly installed. So, our view is that you have a vested interest in working with your tenants to make sure you're specifying the right equipment, that you're doing a design and using technologies that ultimately work for their needs. Keeping them in business, keeping them profitable, helping them save and reduce energy. obviously works for your bottom line. Vacancies are expensive, tenant turnover is expensive, so do what you can to help make sure that your retail tenants know what their needs are, and don't just pitch it out to an engineer. Educate yourself, engage another third party. So with that, we're going to pass the baton to Wilson, who's going to discuss energy management and metering and cost allocations.
So my slides in my section actually want to talk about some interesting energy management insights and ideas. So bear with me here. Basically, when I look at it, what are retail owners really concerned about when it comes to utility bills? Number one, are you being billed correctly? It's really hard to tell because all your properties, they range in terms of the magnitude of your utility bills. If you are allocating and recapturing the utility costs, is it being done in a fair way? How much effort is it taking on you to issue these bills? When it comes to utility bills, you also have to put aside a budget. And are you using your capital effectively? Are you putting too much into your budget so that your capital and it's causing cash flow problems? And the final thing is, when tenants will always be requiring more lighting, more HVAC, how do you manage your energy costs according to these tenant requests? When we look at energy use in retails, it's really hard to manage simply because the range of end-use intensities can be pretty high. In this example, when you compare a grocery to an office, a grocery store operates at around $8.70 per square foot. Office is $2.50. So you're looking at about a 3.5 times difference between the two. So when you have a mixed-use retail property that is all on one common bill, then really your allocation becomes a problem. Normally your small users end up subsidizing your large users, or the landlord basically absorbs all the costs and it's added into the rent. Further complicating it is retail spaces are all purpose-built. So because they're all purpose-built, it's really hard to estimate and have an idea of where the utilities are going to land. Just because you're a restaurant doesn't mean that all restaurants will use the same type of energy. Some fast food chains don't do cooking on site. Some fast food chains do. So their end-use intensities are going to be very different. So there's no one set standard that you can use and estimate, and that's really the complicating factors. When I look at energy management, there's two basically sections. One is your traditional building focus, so your lighting retrofits, your HVAC controls, HVAC retrofits. There's less attention being paid to the people-focused measures. So these are the building operator engagement, your tenant engagement, your continuous monitoring, and finally your submetering. And this is what I want to talk about the most. So these three things, the difficulty is it's hard to validate whether or not they're worth your time. It's hard to come up with how much savings that these measures will result. So your payback calculations is probably impossible. And being retail owners, if you don't know the payback, it's really not justifying your investment. But there are things and strategies that you can overcome and think about these things. Let's start with understanding why engagement is so important. So when we look at a retail owner and his portfolio of buildings, and we've taken out all the buildings that are not similar, so we're only evaluating buildings that have the same age, in the same city, on shared bills, and then you normalize it so that you're trying to compare apples to apples, you would expect that everybody to be operating at around the same level. They're not. Even though the buildings are the same, you will range in terms of how the building's being operated. Some buildings will end up using more energy than others. Why? Why is there a difference? So the biggest example that I've come across in the past is Home Depots. All Home Depots are built to pretty much the same standard, but the end-use intensity for each retail store can range. And it really comes down to people. How your people in that store is operating has a big impact on your end-use utilities. And things like undetected residential usage. So heating circuits not turned off in the summer, that's leading to your some energy use. Your unintended equipment operation. So when your controls are being overridden, but you don't realize it, you don't set it back, that's costing you extra money. Maintenance repair variances. So you've put up all your LEDs, but it's actually being replaced when they burn out by incandescents just because it's a little bit cheaper and it's more readily available. And general awareness, so fans being left on, lights being left on in non-occupied spaces. So these are all variances from site to site that ends up costing you a little bit more. So really, how do you build awareness and engagement? There's ideas like you can do seasonal checklists, do periodic reviews of your operating standards, refresher training because you obviously have site turnover or operation turnover. Make sure you come up with a knowledge sharing program. Like if you learned a lesson in one building, you don't have to learn it again at another. And basically educate and promote awareness to all your operators and tenants. One of the biggest keys to success in this factor is understanding the people factor. We as humans, we're probably more engaged when there's something in it for you. So when I approach these, you need to think from the operator's perspective, what's in it for them. To raise awareness and have engagement, make sure there's some sort of a competition, some sort of a rewards program. This way, if they know there's something in it for them, it's going to drive them to be a little bit more engaged and get the results. So that's working on everybody's benefits. Continuous monitoring. What is continuous monitoring? So it's basically data logging, either utilities, set points, or airflows, a variety of points in your building over a period of time. So with this data, the idea is you can benchmark it or you can set baselines so that any deviation from a baseline you will need to investigate just to understand what's happening. Is it a precursor to a problem? Is it an indication that something should be done? A lot of the times when people come across continuous monitoring, they're turned off by the cost. In reality, you have third-party vendors that's offering real-time solutions, gathering all these data into one single platform so you have a pretty interface to log in, look at your dashboard, and look at your instantaneous usages. As retail owners, do you really need that? Like, is anything that your operations, is anything mission critical that you need to have real-time notification? If not, you probably don't need to sign up for those third-party vendors that's offering these expensive ideas. You can do it pretty much in-house at a small scale and grow from there. Why is continuous monitoring beneficial? First and foremost, it's understanding your building, understanding where your energy is going. Once you've understood where your energy is going, you can at least identify, okay, we have potential in lighting for this building, we have potential in HVAC in this building. It's early detection, so any deviations from your baseline, it's probably an indication that something is wrong. It's worth your time to investigate and get to the bottom of it. It helps maintenance planning. Instead of maintaining things at regular intervals, if you have air pressure signals, you can probably identify when that filter is getting clogged so you replace it at the right time. The biggest thing to me is insurance on capital investment. You've spent all this money onto a fancy control system. How do you know that it continues to work over the period, over the life? When you have continuous monitoring data, again, it goes back to the early detection. You will know that something is up. When something is up, investigate and probably maximizes your capital investments when you go and put in those fancy controls. And then finally, with all this, you can probably be a little bit tighter on your utility budgeting. And when you're a little bit tighter, obviously that's more of an effective use on your capital. We have an interesting case. This is actually an actual meter data from one of our buildings. This is 2 pumps, and this is 2 separate metering points. So you'll see the red and the black. The pump is in a standard duty and backup. Each pump operates for 2 weeks at a time, so that's why you have black, red, black, red, black, red. Now suddenly, in this period, everything went down, anomalies happened. Maintenance people went in and fixed it, and now you have this profile going forward. So what happened is that the maintenance guys went in, made it work, they fixed it, but instead of the duty and backup pump controls, they made both pumps operate at the same time. So what does this mean? Before, in the as designed situation, you're operating at around 63 kilowatt hours a day, $9 a day. After this, you're operating at 95 kilowatts a day and $13.50. So over the course of the year, this is a $1,600 difference. So if you didn't monitor this data and if you didn't catch it, let it run over time, you're at a loss. And that's one of the values. Obviously, being from submetering, we can't not talk about submeters. Going back to the whole wide range of end-use intensities, what is the most fairest way to allocate and recapture your utility costs? How do you encourage conservation? If you pay for your bills, you're probably driving conservation at a much greater success rate. We have an interesting physical example from a commercial retail. This is actually a restaurant in a strip mall, and the restaurant was built with single pass condensing units for the walk-in freezer. And if we look at this, you can see that this meter continues to spin. And simply, if you look to the left, that's your water going straight to drain from your condensing unit. And look at the speed at which this meter is spinning. That's just continuous consumption going down the drain. What's the materiality? When we looked at it, in 1 week it consumed 93 cubes. That's about $325 a week, a materiality of around 17 grand. For a building this size, the annual water utility bill was almost 20, so 80% of usage was attributed to this single restaurant. Obviously, in this case, the payback was really fast. The landlord was absorbing all the water costs. As soon as you implemented this, everybody paid for them, and the landlord stands to benefit at a much greater deal. When does submetering make sense? Obviously, submetering for commercials makes sense when you have a wide range of tenants. When you have a grocer next to a mom and pop's retail or next to a gym, all your stores are operating at different levels. Allocation by square foot is probably not fair. So your smallest users, your small dental offices, are probably subsidizing your grocer with a lot of refrigeration requirements. When does it make sense? When does it not make sense? It's really the small offices where everybody is in office, everybody is just a typical 9 to 5 operating hours. When you have multi-tenants that's the same type, it's probably not worth your time. When you have shared warehouses or shared entities operating under one roof, it's probably not worth your time either. So traditionally, without submetering, you are either absorbing all your utility costs or you are allocating based on a simple square foot. In an ideal submetering world, everybody gets submetered by a single meter. Goes to the tenant, nice and clean. How do you get there, and what's the difficulties? And in reality, it's very difficult to get to the ideal submetering world simply because you have lease agreements that dictate if you can or cannot ask your tenants to pay. It really factors on what type of distribution your building has. So if you're sharing panels between multiple tenants, that's probably not a good idea to submeter it without significant cost to rewire and redistribute your energies. Your installation costs, because your building wasn't designed for submetering or having access to the meters, you're going to have to cut through drywall, make access hatches, probably do a little bit of redistribution work on especially your water pipes. So your one-time installation cost to retrofit your water and electricity is probably pretty significant. So what I want to present is also just ideas on how you can strategize your submetering implementation so that the costs are manageable. The most simple thing is identify your big users. So in a strip mall, if you have a restaurant and 5 office spaces, just meter the restaurant, and everybody else can be equally allocated based on the square foot of the remainder. Nice and easy. This is cost effective, and you don't run into the headaches of making sure everybody is retrofitted and goes through the pain of installing a meter. The number 2 is over time. Every time you have a tenant turnover as part of the build out, you require them to put in a meter. So the benefits of this is obviously as part of the build out, they have to spec the meter, they have to cover the cost of the meter installation and the distribution work. So it mitigates the upfront capital that you would need. Over time, when all the tenants are turned over, you basically have an ideal submetering case. So these two are popular strategies that can be considered when thinking about submetering in retail. So basically, now we go to a quick summary. When you think of energy management, you're not stuck to the traditional energy measures. Things like building awareness, tenant awareness are proven to be effective. It is a little bit difficult to gauge how effective it is, therefore it's hard to do this payback calculations. But when you start small and start in-house, there's probably minimal cost and there's lots of benefit to be reaped. Continuous monitoring, don't have to sign up for something that's real-time, that's offered by third party. You can start simple by just tracking your utility costs month to month and look for the patterns. Meter your main loads, your chillers, your pumps, or your lighting panels. Compare them month to month, see what's happening. That's the easiest way to start continuous monitoring. And then submetering, you can strategize your submetering implementation. You don't have to go all out and meter everybody. You can just meter the large exceptional users. Everybody else shares the remainder based on square foot. And you can ask for tenant turnover. During tenant turnover, make them put in the meters. So that's pretty much it.
Great, thank you, Wilson. Well, I think what we've tried to accomplish here from the panelists is to give the audience some very practical and affordable, easy to implement strategies that can have a material impact on how you operate your business and how competitive you can make your retail spaces. Everyone knows that the retail environment is changing dramatically. So every dollar counts in terms of helping your tenants manage their costs and managing your own costs. So we have a pretty small group here today. I want to thank everyone for attending. But we are certainly more than able. We've got a couple of really bright guys here, willing and able to answer any questions that you have about metering, energy management, or HVAC systems.